Hello students, let's start learning about one interesting concept, trigonometric identities for complementary angles. But wait, what are complementary angles? A pair of angles whose sum equals 90 are called complementary angles. For example, we have two angles A and B, and if angle A plus angle B equals 90, then angle A and angle B are called complementary angles. So can I write angle A as 90 minus angle B? Yes, absolutely. What I've done is just shifted B to this side. For the sake of simplicity, we will write simply A and B instead of angle A and angle B. Now you can ask, what is so special about these trigonometric values of complementary angles that we are studying them? Well, they are special. Let's see how. For that, we again need one right-angled triangle. So let's make our generic triangle ABC right-angled at B. Now this is 90 here, and this angle is theta. What about this angle? We have learned about angles in triangle, that all three angles sum it up to 180. Therefore, angle A plus B plus C equals 180. This is true for this triangle as well. But here, B is 90. Therefore, A plus 90 plus C equals 180. So, remaining two add up to 90, isn't it? Yes. Now in this, if I replace angle A as theta, we get something like this. So now, can we say that for right-angled triangles, the sum of these two remaining angles is always 90? Yes, always. So they are always a pair of complementary angles. This means if A is theta, then C is 90 minus theta. Now what do we do is find the values of sine, cos and tan for both these angles, theta and 90 minus theta from this triangle. Recall our SOHCAHTOA. So we have sine as opposite upon hypotenuse, cos as adjacent upon hypotenuse, and tan as opposite upon adjacent. So for A equal to theta, sine theta is BC upon AC. Similarly, AB being adjacent side, cos theta is AB upon AC, and tan theta is BC upon AB. Can you find the rest of the three ratios for me? Yes, they are easy. Just take the inverse of three ratios which are here. So we have cosec theta as AC upon BC, sec theta as 1 upon cos, that is AC upon AB, and tan theta as 1 upon cot as AB upon BC. Now let us find all six ratios similarly for angle C, that is 90 minus theta. So we have sine of 90 minus theta as AB upon AC. Note that for this angle, opposite side is AB and adjacent side is BC. So cos 90 minus theta is BC upon AC and tan is AB upon BC. Similarly, the remaining six ratios are like this. So what we have is 6 ratios for angle theta and remaining 6 ratios for angle 90 minus theta. In order to compare them, let us write them in table form into two halves of the screen. And this half has ratios of 90 minus theta. Pause the video and observe these ratios carefully. What do you find? Can you figure out some equal or same ratios for both the sides? Yes, there are. Look at this sine theta and cos 90 minus theta. Aren't they equal? Yes, both are BC upon AC. Similarly, we have cos theta and sine 90 minus theta as equals, being AB upon BC. And tan theta equals cot 90 minus theta, being BC upon AB. And remaining three ratios are again paired equal, like this, which is cot theta equals tan 90 minus theta, sec theta equaling cosec 90 minus theta, cosec theta equaling sec 90 minus theta. So we can say that sine of any angle, may it be theta or any other, is equal to cosine of its complementary angle, which is 90 minus theta or 90 minus alpha and so on. Yes, we can definitely. In fact, this is true for all other complementary pairs. We can write them like this. So let us see one example. Say in this triangle, theta is equal to 35 degrees. Therefore, angle C will be, yes, it will be 90 minus theta, that is 90 minus 35, which is equal to 55 degrees. So whatever will be the numerical value of sin 35, it will be same for the cos 55. Say for example, sin 35 comes out to be 1.5. So cos 55 will also be 1.5. On the same lines, value of cos 35 will be equal to the sine of its complementary angle, that is sin 55. And this is true for all other ratios as well. So we say that sine of any angle is equal to the cos of its complementary angle. All you have to do is remember the complementary pairs. But is that so simple? We have 12 ratios, isn't it? 6 of theta and 6 of 90 minus theta. So how do we do that? What do we do to remember them? Let me make it slightly easy for you. List all the 6 ratios again like this. Now separate the ratios as shown. If you can see, this column has ratios without co in their names. That is sine, sec and tan. While this column has all the ratios with co. That is cosine, cosec and cot. So we see that cosine is complementary for sine. Yes, that is why there is a word co here, which means complementary. And to what? It is to sine, thus cosine. Similarly, cosec is complementary to sec, and cot, that is cotangent, is complementary to tan, that is tangent. Now sometimes you might get confused between inverse ratios and complementary ratios. Remember, they are not same. They are different. Inverse ratio is the value turned upside down. Like cosec is sine turned upside down, that is 1 upon sine. While complementary ratios are whose sum is 90. And they are equal, like sine theta is equal to cos 90 minus theta. This means in complementary pair, two angles are equal, while in inverse pair, they may or may not be equal. With one exception, tan and cot are also magically the inverse and complementary ratios. So what we have seen is that sine has cosine as its complementary ratio, and that value of sine of any angle is equal to the cosine of 90 minus that angle. That is complementary angle. And similarly, we have this complementary pairs for all other ratios. So this is what we studied in this video. We will see you with some more interesting concepts in our coming videos.